Okay, I want you to go to page 52 and pause the video while you try the warm-up. Okay, so when you graph these, you have to make sure to label your x-axis really well so that we can see what your zeros are. So I know -1 is a 0, 2 is a 0, and -3 is a 0. We have to be precise in labeling our x-axis. The degree, 4 plus 5 is 9, plus 1 more is 10, so the degree is even. And my leading coefficient is positive, so I know that n behaviors will both go up. So a multiplicity of 4 is an even multiplicity, so that is a tangent 0. This one is tangent. A multiplicity of 5 is odd, so that is a change in concavity or an inflection point. And then the 1, that's straight through. So starting over here, I'm going to come and go straight through -3. I'm going to be tangent at -1. And then a change in concavity, so I'm going to swoop that up and swoop that down and connect. And there is a sketch of what your graph should look like. For number 2, we've got degree. Let's see, it's 1, 10, 11, that's 15, so odd. And the leading coefficient is positive, so this m behavior that way, this m behavior this way. I have a root at 0, at 4, at 1, and -3. Okay, so I got my scale. I got 0, 4, 1, and -3. All right, so here, at -3, it's an even multiplicity, so I'm going to be tangent. At 0, it's a multiplicity of 1, so I'm going to go straight through. I kind of missed there. At +1, it's 1, so I'm going to turn around and go straight through. And then odd here is change in concavity. And there is our graph. Let me get rid of my notes. All right, so check your graph for that one. All right, so now on page 53, I'm going to read Claire and Carmela are having a discussion about how easy it is to graph polynomial functions. Claire states, all you need to know to sketch the graph of a polynomial function is the degree of the polynomial. The degree will tell you the end behavior and the number of times the graph will cross the x-axis. Carmela mostly agreed, but she thought that something was not quite right. What do you think? Is Claire right, and why or why not? Okay, no, Claire's not right. We need the zeros and information about multiplicity of each 0. We also need the leading coefficient sign to determine the end behavior. So whatever you wrote down, update it to that. And now we're going to graph some more. So in number 2, we're given this f of x function. And it says state the x-intercepts, which are the zeros, which are the roots. And we've got a 0 at 0, a 0 at 2, and a 0 at 4. And all of these are single. They all have a multiplicity of 1, so they're all single roots. What's our degree? The degree is 1, 2, 3, so that's odd. The leading coefficient is negative, so my end behaviors go this way. To the left, the end behavior goes up. To the right, the end behavior goes down. All right, so let's mark off our scale. It's 4, 2, we got a 0 at 0, a 0 at 2, a 0 at 4. And then we got my end behavior notes here, and we have to make a rough sketch, making sure to go straight through at each root. And there's our graph. All right, so we're going to keep going. For number 3, now we have x times a trinomial, and we can't see the multiplicity of each 0 until we factor completely. So pause the video here and factor number 3 completely. All right, now I've got some space to factor. So what multiplies to 4 that adds to 4 is 2 and 2. And now since this is a repeated binomial, that's x plus 2 squared. So our x-intercepts are 0 and negative 2. And then let me put a note next to them. 0 is a single root, because that's a multiplicity of 1. And negative 2 is a double root. It's an even multiplicity. Our overall degree is a multiplicity of 1 plus 2 makes 3. The leading coefficient is positive. So our end behaviors go like this. Mark out my scale. 0, negative 2. And that means at negative 2, we have a tangent root. Let me make that a little better. And then straight through. Oh, I didn't do the end behavior. So to the left, as x goes to negative infinity, y goes to infinity. And right, as x goes to infinity, y goes to negative infinity. Okay, pause the video again and factor number 4. There's a greatest common factor of x squared to factor out. So my zeros are 0 and 1. And 0 is now the double root. And 1 is single. So the degree, well, here in standard form, we see the degree is 3, which is odd. The leading coefficient is positive. So again, I've got the same end behavior to fill in. Oops, I got these wrong. Rewind. To the left is negative infinity. To the right is positive infinity. Did you catch my mistake there before I did? Okay, so now let me scale out my zeros. So 0, 1. The origin is my tangent, and 1 is my straight through. Okay. Pause the video here, factor number 5 completely, then we'll factor number 6 completely. All 5 is the difference of perfect squares. But then x squared minus 4 factors more. But x squared plus 4 does not. X squared plus 4, that's going to give me complex solutions. These would be complex roots or imaginary roots. So they're not going to show up in my x-intercepts. They're not going to show up in my graph. So the other zeros are 2 and -2, and they're each single. My overall degree is even. The leading coefficient is positive. Mark off my x-intercepts. And go straight through each root. And now whatever happens down here, we don't know. We don't know how low this y value goes. We don't know if there's, like, I could have drawn the graph like this. Well, that's kind of crooked. But I could draw the graph with other maximums and minimums here. We're just focusing on being precise with our x-intercepts and these multiplicities, which we get from our factored form of the equation. All right, pause the video here. Now I want you to try all of number 6. Factor it completely, graph it. So I'm going to take out my greatest common factor of x. Then factor more, what multiplies to -3 and adds to 2. So we have all single roots at 0, 3, and -1. My degree is odd with a positive leading coefficient, so our end behaviors go this way. To the left is -infinity, to the right is positive. Mark off your x-intercepts. And all of your roots should have gone straight through because they're all single multiplicity. So on page 56, we're not going to really answer that question at the top. Instead, I would like you to practice a few more factoring and graphing problems. So in all of the space on 56, I want you to write down these 4 equations, pause the video, factor completely, and sketch your graph, and then come back and check your answers. So for this first one, actually, I'll just do this first one. It's already factored. We got a root at 3 and 0. I have an even degree because a multiplicity of 1 and 3 makes 4. And then negative leading coefficient, so all of my end behaviors will point down. I'm going to go straight through at 0. Then we have a change in concavity because of that 3rd degree. And your graph should look something like that. I don't really love that change in concavity. There we go. Connect your, that looks better. All right, for the middle one, there is a greatest common factor of 3x squared I can factor out. Then I have to factor again. I have a difference of squares that keeps factoring. So I have a 0 at 0, at 5, and -5. We have an even degree, positive leading coefficient. Both end behaviors go up. and we are tangent at 0. But straight through at the other roots. And that makes my favorite graph. It's a W. All right, for the right-hand side one, there's a greatest common factor of x cubed. But then we have to factor more. So what multiplies to negative 24, that adds to 2, that's negative 6 and 4. So we have roots at 0, 6, and negative 4. And at 0, it's that change in concavity. So I'm going to do that first. Actually, no, I'm not. I'm going to figure out my end behavior. Odd degree, positive leading coefficient this way. This way. So we're going to go straight through here and straight through here. So this one, I'm going to change the concavity. Let me try again. And connect to my other pieces. And there's our graph. All right, last but not least, 3x squared plus 13x minus 10. This is a split the middle or box method factoring. Don't forget about our quadratic factoring. So 3 times negative 10 is negative 30. I want to add to positive 13, so I'm going to do, let's see, 1 and 30, 2 and 15, 3 and 10. We want to add to a positive, so the smaller number is negative. Oh, here's our pair. So you can box method, you can split the middle. Uh-oh. No. All right. 2 has to be x and negative 2, which makes this 3x, which makes this 5. So 3x. That is going to be a problem. We got 3x minus 2x. Come on, pen, hang in there. We're almost done. Don't glitch on me now. No. Stand by. X plus 5 equals 0. So our roots are going to be x is 2/3 and negative 5. Set each factor equal to 0 and solve. So when I go to scale out my graph, 1, 2, negative 5, 2, 3, 4, 5. There's negative 5. 2/3 is 0.6. Repeating. It's in here between 0 and 1. Even degree, positive leading coefficient, multiplicities of 1. So we go straight through. Come on. Third time. There we go. Straight through our roots. Okay, so now your homework, 1 through 7, show your factoring and then sketch the graphs.